Assalamualaikum warahmatullahi wabarakatuh. Very good day to all of you. Now we are going to our 11th lecture, which is the maintenance and repair technology. And this today's topic will be the pump and valve. In common system, in HVAC system, we have a lot of pump and valve, which is uh, to make sure we accelerate and move forward our fluid from one to another. For example, from the chiller plant room, we have the chill water, and to make sure we can deliver the chill water to the air handling unit, the fan coil unit, or to distribute the chill water to entire building, we must use the pump. And also to control that particular flow inside the piping, we need to use the valve. So that's why the important use of pump and also the valve. The first one that we have that we are going to look is the valve. So the definition of valve. So like previously I mentioned, the valve is one component to control or regulate the amount and the direction of our fluid in a piping system. So when we say we want to control it, we can have either too much bigger flow or we want small flow, and the direction also either we want to the left hand side, right hand side, and which is the direction either we want to go to that piping or that particular piping. So that's why the definition is want to control and direction of the piping system. So typically, and it is used usually, the valve is made of bronze, brass, iron, and steel alloy. So actually, this particular material we use as a valve to make sure it is not corrode easily. So what we have, the component inside the valve is actually the valve body, packing, disc, packing gauge, nut, seat, stem, bonnet, and the wheel. So this is basically the component inside the valve. So now for the valve, we have two basic group, which is we have the stop valve and we have the check valve. So this is commonly you will heard during when you are in industry. What the stop valve and the check valve. What is the function of stop valve? The function is to shut or partially shut off the flow. We want to close or partially close the flow inside the piping. So example of stop valve is the globe valve, gate valve, plug valve, needle, and butterfly type. And then we have also the check valve. So the check valve function is to make sure the flow in the piping is flow in only one direction. So there will be no back pass or U-turn of the flow inside the piping system. So the example of check valve is ball check, swing check, and lift check. So we also have special type of valve, which is the relief valve, pressure reducing valve, and we have also remote operated valve. Let's look into the first one, which is the stop valve. So this is most common type of valve, which is the stop valve. And then the stop valve can be used in steam, air, water, and oil line. The disc attached to the valve stem thrust against to set shut off the flow of the fluid. So somehow the advantage is used for the throttling, and then the disadvantage of globe valve is the flow resistance. So this is the example of side drawing for the globe valve. As you can see here, this is the wheel nut, stem, which is the one rod here, packing nut, bonnet. So actually the flow will be coming through here, and this is how we control either we want up or down the road to make sure the dishwasher is going to up or down, and then the valve seat will be control the flow, and then the dishwasher will be control the direction of valve seat here to make sure the flow will be coming stop like here, right? We have also the stop valve, which is to use in a straight line of flow, and then the gate for the stop valve is usually waist shape or vertical disc. So this is the example cutaway view of a gate valve to make sure the flow is coming. So this is where the control, the gate or the disc is to control the flow inside the valve itself. For the butterfly valve, usually will be used in water, fuel, and ventilation system. And then because why? Because it is more lightweight and quick acting, but somehow the disadvantages of the stop valve is it can leak early and only one flow throttle. Somehow compared to the ball valve, it is similar function like the butterfly valve, but normally for the ball valve, it is normally found in seawater, sanitary, trim and drain, and hydraulic system. Based on the specification and material of the ball valve, because it be used in some of the special fluid system. So this is the example of butterfly type disc. So actually this is the handle of the to control the position of this inside the valve. So usually it will be close here to make sure there is no flow coming in. But somehow when we want to open the valve, and then we will be control at the handle, and then the butterfly type disc will be rotate from 180 degree to make sure there is flow coming in here, right? So this is what we call the butterfly valve. So usually it will be located and using in the big size of pipe. Then the next one we have the check valve, which is control the direction of flow, and it is operated by flow of fluid in the pipe. So several type of check valve we have is swing check, lift check, and ball check. This is the example of swing check valve layout. As you can see, the flow is coming from here to make sure the flow is going to the outlet. So there is hinge pin here to control the disc nut, and then it can going down or upward to make sure there is flow coming in here. So that's why we call it a swing check valve. So it will going like this, right? Another type of valve that we have also the relief valve. So relief valve usually will be used to protect the piping system. So usually in the piping system, it is a closed loop and closed system. So actually maybe somehow due to several things happen inside along the way of the system, there will be too much of pressure. So the relief pressure is function to protect the piping system from the excessive pressure. Alright, so actually the relief valve will be opened automatically when fluid pressure become too high. So there is some sort of several limitation for the pressure inside the piping system. So when it detects there is too much of pressure inside the piping system, since it is a closed system, so that's why it will be open automatically. So then after it's open, it will relieve the pressure set by adjusting the screw. Another one that we have is the pressure reducing valve. It is used automatically provide steady lower pressure to a system from high pressure source. So actually it will reduce pressure from high pressure to low pressure. So that's why it is called pressure reducing. It reduces pressure from high to low. So somehow it is used usually for the air side, lubrication oil, seawater, and other type of system. So when we call it as pressure reducing valve, actually the inlet pressure will be coming from here, and then before we did control to the outlet, there will be some compartment here to make sure it can reduce the pressure here. So there will be one low one handle to control the lower output and higher output the pressure, and there is one diaphragm here to make sure it's control the flow by the function of the spring here. And then it's coming here also, there is one component which is what we call the adjustable orifice, to make sure it can control the flow, to make sure the flow is coming at slow flow before it's going to the outlet. So this is where it can reduce the pressure at one part, which is by regulate the spring here to make sure it is reduce the flow, and then going to the one compartment here before going to the outlet. The next one that we have this remote operated valve, which is the valve that allow operation from distant station. So usually it will be the type of remote operated valve is mechanical, hydraulic, and motor, and also solenoid. So each and every single type they have their own function and specification, which is the mechanical use reach rod and gears, and hydraulic one is used for fluid and piston setup. Then motor is used an electric or pneumatic motor, and then with the solenoid it is used coil and core mechanism to open or close on an electric signal of the flow to make sure it is closed or open the valve. The next one that we are going to look into is the pump. So actually the pump will be flow any kind of fluid to make sure it can deliver up to what we want at which place that we want. For example, what is the definition of pump? This is actually the definition of pump is the device that use an external power. So usually it is using external power of electrical power source to apply force to a fluid in order to move it from one place to another. So that's why I say we want to deliver the air, the water. We want to deliver chill water, for example, in HVAC system from one place to another, from the chiller plant room to the AHU system or the building. For example, also maybe you have one tank here of water here. We want to make sure we can deliver the water to the building. So we have to use pump here to make sure we can deliver the water from one tank to another to entire building. So if we doesn't use the pump, the only way to deliver the water is by using gravitational force. Maybe we need to put the tank up here, but actually it cannot deliver up to any places that we want. So we still need to have the external power here to make sure we can force the fluid in any places that we want. Okay, something that must be overcome by the pump is the frictional force from large quantity of fluid, and also the difference in static pressure between two locations. So actually there is static pressure inside the piping system itself. So that's why we need to make sure we have the velocity that desired and we want. How many velocity of water that we want to deliver from one place to another. So this is very important to make sure we can select correctly our pump. So for the pump, so I believe you guys have learned about the pump on how working principle and operation of the pump during the subject of fluid mechanics, for example. So in here we have the pressure head, which is to measure the fluid mechanics. So this is usually what we call the potential energy, and then we have also the velocity head, which we want to measure the fluid's mechanical also of kinetic energy. So in here we have the friction head to make sure we can measure the energy loss that hits fluid, and then we also have the bottom line, which is the total energy. The control volume is constant under certain condition here. So in a pump we have a drive mechanism. We will maybe use the steam, electric, or any gear, so as function as the external power source here. Alright, and then we have the pump shaft. and then we have the impeller or piston here, and then we have the casing which cover up all the